Today, what I will quickly cover is basically telephony basics. So what we discuss is that contact centers are a software. Contact center technology is a technology that allows uh, people in the organization to connect with the customers outside the organization. For this particular course or curriculum, we are discussing about telephony or call center or telephony part of the contact center. So your telephony becomes the key part, that how a telephone call made from a mobile phone will land on an agent desk, okay, which is a part of this contact center setup. So we will take a look at telephony in totality, that how did it originate, and how did it finally evolve to the today's voice over IP technologies. So if you go by the history of communication or history of telecommunication, uh, we would have started as smoke signals at some point of time. Then birds were used for carrying the letters. At some point of time, Morse code was invented. Then radio was invented, and at some point of time, telephone lines came in. These were the initial telephone calls, where two people could speak to each other. Then came fax. Then came internet and email and everything. Uh, Then finally, there was a time when wireless communication developed, and today we have got mobile phones. So today we can reach anywhere from anywhere using simple device in our hand. So this is a brief history of communication or telecommunication. Very initially, the telephony is nothing but when I refer to telephony, it's a technology behind voice communication. So telephony allows customers sitting in their homes connect to businesses over phone calls. So this is what we are discussing here. How does it actually happen? Okay. Now, for a contact center, telephony systems are the backbone. They carry voice from the customer to the agent and vice versa, whether the agent is sitting on a landline, soft phone, or a browser. Okay. If we talk about evolution, the start was simple. Our voice would travel over a wired connection from one point to another. Uh, Eventually, it became so instead of wire, we started using electrical wires now. So the plain old telephony system, as it call it, POTS, was invented. So here there were a twisted pair of wires from the local phone office to the building in which your phone was kept. And so this was our first telephony service. Entire our voice traveled over, uh, light electric currents, uh, and this has remained the same throughout. So how does it work with that? There was a PSTN cloud. So when I say PSTN cloud, I mean a mesh of wires spread across the city or the country, where we had these central offices or local exchanges on the boundary of this mesh. And from there, these central offices, the wires will go to your homes. And uh, so this is a circuit switch network, as we say it. So basically, for a person A to reach person B, uh, a electrical circuit must be completed. So this PSTN cloud and central offices or local exchanges ensure that when person A is trying to reach person B, there is a proper circuit in between. Okay, this is basically analog technology. So when we talk about analog technology, we are talking about analog signal. You might have read in your maybe colleges that what is the analog signal? It's basically it's a waveform, sine waveform as we call it. So in which the measurement that we are measuring changes continuously with respect to time. Okay, and so the common radio signals or analog signals today, we have got radio waves, television waves, and sound waves, right? Uh, Now, analog signals have their own problems. Like, for example, when you talk about analog they are prone to the strength of the signal depletes over time and as well as over the distance. Analog signals are susceptible to interference. So if we talk about a telephone line which is in which electrical current is taking our voice, uh, any electrical interference will cause it to get manipulated or get modified. So there were problems. So uh, voice technology was continuously evolved over time. So after POTS, ISDN came in which we converted analog signals into digital signals. So basically now we carried our voice as bits, 1010 and so on. Beyond that, but ISDN was also a circuit switch technology in which you had independent circuits carrying this bits from one point to another. Then came VoIP, where we actually converted our voice into data packets. So as we browse internet, as we send data from one point to another, similar way we can send our voice from one point to another. Uh, then came WebRTC. That is where you can say uh, we now for VoIP. One thing was there that is still now you did not need any special circuit. Your voice could travel over the same network that you are having in your home, in your offices. So, but still you needed SIP endpoints or SIP devices. So to terminate these calls, so either you were using a soft phone or a IP phone. We will see to it also in detail. But then came WebRTC. This was made possible by HTML5, in which your browser could carry your voice and video. So today, when we are having this meet call, we are just logged in with browser. We are not having any special device, any special network is there. We are just talking to each other as if we are just browsing internet, right? So that is where WebRTC came in. And in parallel, this our mobile phones also came in. So GSM technologies were developed. Volt was developed. Volt is like a similar thing to VoIP in case of mobile networks. But for our discussion, we are not discussing GSM in this curriculum, so that is out of scope. Other things we will discuss. So one important thing is that how your analog is converted to digital. It's basically a three-step process in which you will first of all have a analog wave. So you can see the waveform, it is varying continuously over time. So what we do is we sample this waveform. Sampling means that taking a measurement of this waveform after every few seconds. Okay, and then whatever value is there, we convert that value into a binary number. Okay, so sample, quantize, and encode, and this becomes your 01001. That is our digital signal. Okay, so this is the concept behind ISDN. So you will use something like a ISDN modem, right, to actually achieve this purpose. So your telephony service provider will put special equipments at your home and will terminate ISDN lines over there. And those ISDN lines will be connected to your ISDN phone. So even the phones were different. Your backend, connectivity was different. Everything was specially for ISDN. For audio signals, what we do is, in case of sampling, we do it 8,000 times per second. And each sample is converted into 8-bit binary number. So if you see this particular thing over here, so we are doing sampling 8,000 times per second. Okay, so that's how we do it. And then we convert everything into a 8-bit binary number. So the raw speech signal becomes 8 into 8,000, that is 64,000 bits per second, or 64 kbps. This is our raw speech signal in case of digital signal. Okay. So this is also known as raw signal, in which there is no loss of voice, or the quality is the best, as we say it. So ISDN network, if you will understand, is it's look like this. So basically, these will be your telco providers. These pillars, from there, some equipment will come to your office. So ISDN bridge will come, which will connect to your telephones. These are ISDN telephones, not normal ones. Also, it will go to your normal hub or switch, and you will be connected to LAN. So ISDN can carry both your voice and data, normal data that you use over this connection, and you can connect with each other or the network. Okay, but still, as you can see, this is a complete circuit. So as we call it, it's a circuit switch network uh, that enables transmission of both data and voice over a digital line. Okay. So I have repeatedly said circuit switch network. So what is the circuit switch network? So in a circuit switch network, if this system has to speak with, say, this system, a continuous circuit must be available, right? As you can see, uh, the circuit must be completed. Okay, the end-to-end connection is required. If end-to-end connection is not there, uh, this systems will not be able to speak with each other. So wherever you see this switching happening, this particular blue lines, so here we can say some switching is happening. So these are done by the local branches or now even automatically. Okay. So suppose this system has to speak with this system now. So obviously this will be connected to this particular point. Then this particular blue line will point to this and so on. And multiple places switching can happen because you're talking about a large country or large state. So there will be multiple offices, multiple central offices. At all these places, the switching must happen to make this connection possible. Okay, both PSTN and ISDN both are circuit switch technology. So ISDN, talking about ISDN in detail. So one thing that I am clarifying is that ISDN, so PSTN has almost become obsolete today. No one uses it. The backbone of telcos may be still on that, but we normally don't use it in our homes or offices. ISDN is still kind of there, but practically it is also now almost what do you say? It has just become a backbone concept. Most of our offices and homes are today not on ISDN. Okay, so today your Wi-Fi router gives you a data connection. You don't need a ISDN device at your home or office. In enterprise telephony, where these telephone lines terminate, you may come across ISDN lines, but it is very rare now. We are still looking at them for academic purposes, but most of your work will be on VoIP only. So in ISDN, what happens is that there are two logical channels in a ISDN line. One is called a B channel, which is a 64 kbps channel, and this channel actually carries your voice and data. Okay, so this is a bearer channel, and then we have a D channel. So D channel can be 16 to 64 kbps, but this is basically signaling. So even from the telco, a single wire is coming. On that wire, logically it is divided into B channels and D channels. D channel does not carry any active data. Then we have got two types of ISDN lines. One is called basic rate interface. It's basically a low level service in which you get two B channels and one D channel. PRI is a primary rate interface, which is a higher level of service. It provides you, so it also comes in two forms. One is T1/J1, used in USA and Japan respectively, in which you get 23 B channels and one D channel. And even which is mostly used in India and Europe, which has got 30 B channels and one D channel. So practically what we are saying is that on one even line that we have in our country, we have 30 separate channels on which we can do 30 simultaneous calls. Okay, cumulatively they become a bandwidth of 2.048 Mbps. Okay, because each channel is of 64 kbps. So when we use ISDN lines, as we have said that suppose I am using even line. So from telco, a single line is coming, it goes into an ISDN modem or ISDN device. From there, an even line comes. Traditionally, what we used to do was we terminated into a PBX. PBX is nothing but a private branch exchange, which allows these 30 logical channels to be distributed to 30 phones in our offices. You might have come across these PBX in hospitals, in hotels, right? So you visit a hotel, in every room in the hotel, there is a phone. Using that phone, you can connect with each other, just dialing the room number, or you can dial a 0 and then you can dial outside and so on. All these are called PBX features. So basically, PBX is acting like a private branch, private telco branch for you, and it has got certain functionalities and capabilities. So you can dial 9 and you will be connected to, say, reception. You can dial 8, you will be connected to a room service. So all these things are like configured in the PBX, like shortcuts. And obviously, the main role is that if I have got, say, 100-room hotel with me, I will go to telco and take 4 lines from him, and these 4 lines will go into PBX, and then PBX will be connected to these different telephones in different rooms. Okay. So this is how a PBX setup will look like. I'm just trying to show it to you. Again, not you might not encounter this, or your role might not really need you to be worried about this. So from telco, again, ISDN line is coming. It is going to this device. From there, the even lines come. So these are the PBX cards. You can see all these are cards. These will have even ports in them, in which the even lines will go, or the ISDN lines will go. From here, what you say, a cable comes out, in which you can see there are multiple copper wires, okay, pair of copper wires. So they can be 100, 200, 300, depending upon the need. They go into something, this particular box, this chrome box, okay. You can see on the left hand side, we will punch in the wires coming from the PBX. On the right hand side, we will punch in the wires coming from our telephone or our rooms, right? So all these wires are like, this cabling is done. You don't see these wires outside, but definitely you would have seen these kind of ports. Okay, so these kind of ports, if you can see here also, these are you can see on the wall. And from the phone, this particular cable comes. This is normally called RJ11 connector, in which there are 4 pins, and these RJ11 connectors go into these ports. At some point of time, this was very popular. Almost everywhere this was used, but now this is increasingly becoming, again, not so popular because VoIP is taking over, right? So I am just showing this to you to have some idea of how the ISDN setup works. The important part is, from telco, there are not 30 lines coming. In case of PSTN, if I have to connect 30 phones in my office over PSTN, from the telco itself, 30 lines will come. Okay. Each line is separate copper wire pair. Okay. But in case of PBX setup or a even setup, this will be the scenario. Then we move to something called VoIP. Okay. Now VoIP is nothing but we are sending voice over internet protocol. So ISDN and VoIP, they are both able to transmit voice and data, but the underlying infrastructure and operation is completely different. ISDN uses dedicated digital phone lines, while VoIP relies on internet connection. So in VoIP, we use something called a codec. So basically, what codec entire operation that happens in a VoIP case is that we convert analog to digital, and then we encode it. And after encoding, we packetize it. Okay. So basically, when you converted your analog signal into, so whenever I'm speaking on the phone, or right now also whenever I'm speaking to you right now, my voice is analog, right? My voice will go into my system, to my microphone. There, my browser will be doing all this stuff, that it will be converting it to a digital, and then it will encode it, packetize it, and then it becomes a IP packet. Okay. In case of WebRTC, it goes one step further. It also kinds of what do you say, encrypts it. Okay. So in WebRTC, there is an inbuilt encryption, but if we just rely on VoIP for now, once the packet is made, it becomes an IP packet. So if you remember your OSI layer, at layer 3, IP packets are there, and your routers can route these IP packets. This is the source IP address and the destination IP address, right? So whatever the destination IP address would be put, simply these packets will be transmitted to that place. There again, there will be a SIP device. It will again do the decoding part of it. and you will be able to hear the voice. Okay. So in VoIP, everything is transmitted on the network as a data. Okay. One thing is that in enterprises, in large organizations, we might logically separate our voice network from our data network, but that is a separate discussion altogether. Uh, in a nutshell, there is no difference between a data packet of a voice call and a data packet that you are sending when you are trying to transmit a file. Okay. So if someone asks you what is the difference between ISDN and VoIP, in ISDN we need dedicated lines. In VoIP we just need network. It is circuit switched, so we need to establish dedicated connection. Okay, for each call, it is in case of VoIP there is no circuit needed. It's basically packet switched. Okay, so it's flexible. ISDN is hardware dependent. You need complete hardware infra from end to end. VoIP is not hardware dependent. It's software compatible. You can have soft phones on your system, and that's about it. You don't need any other hardware as such. ISDN offers better transfer rates than analog, but then VoIP also can use the same data transfer rates. VoIP is cost effective because you can actually compress your data as well, and that is the main reason why VoIP became so popular. And VoIP can have so when we moved from analog to ISDN, we were able to have some more features like caller ID and things like that. In VoIP, we can extend it this much further. We can do call forwarding, voicemail, conferencing, all those things are possible. So this is broadly the thing. So in VoIP, voice travels as data packets, as we have seen. It is same as when we browse the website, following the TCP/IP model. So again, not to get confused, practical model is TCP/IP and theoretical model is OSI model. So VoIP uses at the transport layer, we normally use UDP for voice because it's a real-time real-time data. But it is not like you cannot use TCP. You can still use TCP also. Today, the protocol, okay, in VoIP, we also have some protocols like SIP and S323. Today, SIP has become a de facto. Now we can even use VoIP and SIP interchangeably. SIP works on the port number 5060, and in case of a VoIP call, SIP is basically used for signaling part to establish the call, and your voice actually travels over RTP, real-time protocol, which normally uses the ports number ranging between 10,000 to 20,000. Okay, we don't need any dedicated channels. Okay, so in case of ISDN, I told you that if I am using one even line, I have 30 channels. I can make 30 concurrent calls. But in case of VoIP, there is no concept of channels. We are now only talking about bandwidth, and that depends upon which codec we are using. If you are using a raw codec like ALO or ULO, which is the raw codec we discussed, which consumes 64 kbps per call, and I want to make 100 calls, concurrent calls, then I will go to my telco and say that I just want 64 kbps into 100, maybe 6 mbps of bandwidth. So I will not ask him for channels. I will just simply ask him for that this much calls I want to make, and the telephony service provider will give us that much bandwidth. G729 and G722 that is written over here, these are also codecs. Okay, so these codecs are very important in VoIP. These are kind of compressed codecs. So instead of consuming 64 kbps per call, you might consume only 24 kbps per call. Okay, so that is one of the reasons VoIP became popular, because if I'm talking about 2000s or 1990s and 2000s, the bandwidth was very costly, right? Today we have 1 Mbps of bandwidth available as free on our mobile phones, but maybe more than that. I think bandwidth is more. So at that time it was very difficult to get it, and just being able to make say more calls on the same amount of bandwidth was a huge cost advantage, and that also allowed so many call centers that were established in India and developing countries, for the countries like US and UK, because we were able to save on the telephony cost. Okay. So when we use VoIP, what happens? So we have got multiple scenarios in where we can use VoIP. Basically, one thing is clear that wherever I am using VoIP, I am going to use IP network. There can be a scenario in which we get ISDN lines from the telco, and we put something called a VoIP gateway. So VoIP gateway or a PRI gateway will have options where you can terminate the ISDN lines on it, and the output of it will be SIP or VoIP. And then these can go into different devices, IP phones, soft phones. One more device that is there is called ATA. Okay. Again, now not very popular, but ATA can convert your normal phone into a SIP phone. So this has this normal RJ11 port also will be there, and a RJ45 port also will be there. Your RJ45 port will connect to your network, and this device will convert this particular phone into a SIP phone or a IP phone. Okay. Then obviously we can take directly a SIP trunk from the telco today. This is more popular. So the telco will terminate this SIP trunk on some of the device that they give. From there, you can simply connect it to your LAN, basically your switch. And from there, the connections can go to IP phones, soft phones, and then again, your analog ATA. Okay. Another case can be that which is where you can actually use VoIP or SIP today to actually make calls over VoIP, right? So there are many public VoIP providers available. Okay, and you can simply log into their website, create your own SIP account, download a SIP phone on your system, a soft phone, and connect it. So whenever you will create an account on these websites, they will give you some SIP account information, which you will configure it at your end, and basically you can make internet calls from there. Today, this has become less popular because anyhow our international calling rates have reduced. But in those times where your ISD calls were very costly, this could save a lot of cost also. This is not legal as such in India because you are kind of bypassing the local telco. But for few things, for experimentation purposes, you can still do it. So coming on to the WebRTC part. So WebRTC technology so basically here, what we are doing is we are doing a real-time voice and video calls, live chat, peer-to-peer file sharing into web browsers, right? So these are embedded into web browser itself. You don't need any plugins, you don't need any software, you don't need any SIP phones. So basically, you just need a WebRTC. So a browser is WebRTC compatible. Most of the today WebRTC compatible. You just need a WebRTC server to make this happen. Okay. Obviously, there are a lot of configurations that go into it, but those configurations are beyond the scope of current discussion. But this is what is WebRTC. So when we use WebRTC, practically we are just there can be a WebRTC server on your local network. There can be a WebRTC server on a cloud network. Basically, you don't need just anything. You just need a browser and the network connectivity. Okay, so no devices needed, nothing needed. At most, you can use your headphone if you want, but that's about it. Okay. So if you were to differentiate between these three things, ISDN, zip trunk, and WebRTC. So in case of ISDN, it's a digital line. In case of SIP, it's an IP network. WebRTC is browser plus IP. Setup cost of ISDN is very high as compared to SIP, as compared to WebRTC. Scalability, again, WebRTC is unlimited scalable. You don't need anything. So as many as people can do it. In case of ISDN, you need ISDN cards, PBX. In SIP trunk, you need soft switch, IP phones. In WebRTC, you only need a browser. Use case of ISDN is legacy stable traffic. SIP is modern contact centers, and WebRTC is cloud contact centers and remote agents. So because we don't have any reliance on the hardware, local hardware, WebRTC actually allows us to host our entire contact center on the cloud. So in summary, what you should now understand is telephony is the core of the voice-based systems. We have moved from analog to digital to internet-based calling. ISDN peer alliance offer up to 30 voice channels are still used in India for stability and compliance. So you might come across them. VoIP and SIP allows voice to travel over IP networks, enabling scalable, flexible, and cost-effective setups. WebRTC allows real-time voice and video communication directly in the web browser, no software needed. Regardless of the method, calls pass through the backend, telco, soft switch, routing, agent, CRM. So there is a backend flow around these calls. So even if telco will giving us the calls, it will go through our call center software, and then it will land on the agent desk. Understand these technologies help you to configure, troubleshoot, and support modern contact center infrastructure.